Okay, yeah. Again, thank you for coming and welcome to Aptoide. So today we're going to try to explain to you what's RxJava, an introduction about it, but not specifically about RxJava. We're going to talk about reactive programming that has several implementations in different languages, not only in Java, but it's pretty popular in a Java world and Android world. So first of all, reactive, sometimes it's misleading. So let's talk about ReactiveX. That's the framework that is implemented in several different languages. And so not to be misled by something, some different word like reactive, we are going to I'll also always refer as ReactiveX. So ReactiveX is a combination of the best ideas from the observer pattern, the iterator pattern, and functional programming. This is does not explain that much, so I will start with an image. So this is a marble diagram. It's used, everybody here that's already programmed a little bit using Rx saw something like that. So it's a string of data, of circles at the top, and this stream of items goes through an operator, a map operator, that will transform the circle into a triangle. So the important point here is that this stream of data is iterated. So that's the iterable pattern here through the operator. And also below you have another stream that can be observed. And the complexity of creating these triangles will be abstract. So if someone is observing the stream of triangles, it will be not know about the complexity of generating this stream. Also, another interesting fact is that you can combine different streams of data. Here we have a different operator that is the merge operator. It combines two different streams into just one. Another important thing that we will have to understand about these diagrams is what the X there that comes down means. This is an error. So the first stream had an error during his processing, and this error is propagated. So you see that the pink circle is never emitted in the final stream, in the resulting stream, because an error occurred, so it's propagated. Also, there's a straight line after the pink circle. That's the terminal event, the completion event. Both of these events are terminal events. When they happen, the stream will never emit items anymore. So they are terminal events, and this is important to understand. So what ReactiveX helps us to do is to create those streams, and we will see how we can do that in Java. Also, ReactiveX makes it easy for us to combine those streams and use operators to operate on them. And finally, we can listen to those streams and perform side effects. Usually, this happens in the view layer of our application, when we want to update a list of items, or we want to update anything else on the view. Usually, it happens on the view layer of our application. Okay, I'm talking about a lot here, but I think it's better if I show you some code. You know, the examples will be in Java, but it doesn't matter because, like I told you, there are many implementations and they are really, really similar. So if you are not a Java developer or an Android developer, you can use that to learn Rx Python or RxJS. That's the JavaScript implementation. So yes, RxJava. RxJava was actually ported from Rx.net by Netflix. So a guy named Ben Christensen did that. He took Rx.net and ported to RxJava, and today RxJava is the most popular implementation of ReactiveX. So let's start with some examples. Actually, this is going to be our example throughout the presentation. So we'll define a dog interface that has a name and is trained or not trained dog. And also I'll have another interface, that's the dog handler, the guy who trains the dog. So you see that the dog handler returns an observable of dog. This observable represents the stream of data. So it's a stream of dogs. This is what this dog handler is going to return to us when I call this method. So here we have a factory to create it. I don't care about the implementation right now. So the dog handler will be named John. And John will train the dogs. No, this part is only declarative right now. We are not performing side effects yet. So, and this is important. There are two different phases that we want, and we want to keep them separated usually. So we are going to declare a lot of things, a lot of combinations in our operators, using operators and creating new observables, a chain of observables. And in the end, we are going to start to listen to this stream and perform the side effects. So important that we try to keep this separated. First we declare, and then we actually perform the side effects. And this is when it starts to become imperative, when we start to listen to it. Before that is only declarative. Okay, let's create some observables then. So here's our John implementation of dog handler. And the first and the simplest way to create an observable is by using the just static method in the observable class. We will just create a new dummy dog. It's not trained, but it's a dog, implements dog interface. His name is Marley. So what this observable is going to do is just emit the Marley dog, and then it's going to complete. You see by the completion event that I told you before, it's completed. It's not going to emit anything else anymore. It's pretty simple. There's another one that receives any object that implements the iterable interface in Java. So there can be a list, a set, or any other object that implements this interface. In that case, I'm creating a list using the asList method. So I have a list of dogs, Marley, Rocky, and Daisy. And what will happen here is that this list is going to be emitted one item each time. So using the from method. So from a list of iterables, I emit one item each time, and then I complete. You see by the completion event. Also, this is slightly different, but it's using from callable static method. So it receives a function, and this function will return the dog. This is really, really important for us to notice the difference between declarative and imperative. This kind of approach will defer the creation of this dummy dog from when someone starts to listen to this observable. On the other hand, when we create using the just method, the dog will be created beforehand. And when someone starts to listen to it, it will be created already. So you imagine, if this dog is expensive to create, it's better for us if we can defer to the moment when someone starts to listen to the stream. And we will see why is that afterwards. Because who starts to listen can set some, define how this stream is going to behave in certain ways. But it's also important to keep this idea of being declarative and afterwards performing the side effects being imperative. Okay, so this is the marble diagram from callable. It's just going to emit the item and then complete. But only the item will only be created when someone starts to listen to this observable. There's a different one that it's more powerful than from callable. That's called defer. The defer operator will return an observable. So it's the same thing. It's a function, but instead of returning just a dog, it will return an observable that return a dog. A stream of dogs. So it's much more powerful. In that case, I'm just using just. So this the observable I'm returning, it's going to emit the Marley dog and then complete. But you can see in the diagram that sometimes it's not going to be like that. When I start to listen, maybe I will emit more than one item because it's an observable that's being created. So here it's 3 items, and when someone else subscribes to this observable, starts to listen to this observable, it's going to be again 3 items. So it's much more powerful. Okay, there's another method that's called create, but this is not recommended at all. It seems to be really easy to create observables using the create method, but it's not. There are several complications that you may have, and about some topics I'm not going to discuss today. But what I recommend and why I've seen people that are experienced with ReactVex recommend is not to use this method. Try to always use the other ones that are simpler to create your observables. Okay, now is when things start to get interesting. When we are able to combine those observables and to apply different operators, creating a chain of declarative observables. So we'll start by creating a list with our from operator. And now we are going to actually train the dogs, because we were returning only dummy dogs, and now we need trained ones. So we're going to use the map method, the map operator, sorry. The map operator is going to do what we saw before. It's quite simple, this operator. It will turn dummy dogs that now are represented by circles into trained dogs that are triangles. So whoever listens to this observable will receive only trained dogs. So let's say that John doesn't want to train Rocky because Rocky is he fights too much. It's a complicated dog to train. So let's filter Rocky. And so we don't need to train him. So we are going to use a new operator called filter. So we receive a dummy dog, and we say, if his name is not Rocky, let's continue in the chain. So it will be mapped and will be trained. But if it's Rocky, it's going to be filtered out. So again, another marble diagram. Only circles will continue because we are filtering only circles. So triangles or anything else is not going to be filtered. It's not going to continue in the chain. So let's introduce Mary. Mary is going to train Rocky because John didn't want to. So she's also a dog handler, and she also maps the dummy dog to a trained dog. Okay, so here we have John, now we have Mary. So we're going to merge them. Since we want all the dogs, we are going to merge John's dogs and Mary's dogs. And to do that, we are going to use the merge operator. We already saw that. So if we have different colors of circles, all of them are going to be merged, and the final stream is going to be made by all of them. If an error occurs in one of these streams, then it stops, and we are not going to receive the other item. Okay, and let's say that, but there's a problem with the merge operator. Merge operator does not keep the order of the dogs. So if we want to be sure that first we're going to receive the dogs trained by John, and only afterwards we are going to receive the dogs trained by Mary, we have to use the concat operator. It's a different one, and we'll see that it keeps the order. And how it does that? He does that because he waits for the completion event of John. So that's the reason why, that's the starting point for Mary, to subscribe to Mary. So first John's dogs, a completion event, and then I can start to receiving Mary's dogs. So the completion event is the key to understand how concat works. And it's really necessary. If we don't have it, it's not going to work properly. So here I'm going to discuss a common pattern that we have at least in Android. We have sometimes some persistent layer of data that we query to create our views. And the interesting part of this persistent layer is that it is reactive. It means that in our case, if we have a dog repository, if we add a new dog, it will be emitted. And then we can react to this new dog. This is cool. So here, John is going to use the dog repository to get the dogs instead of creating them manually. So we get the dogs stored in the repository. We filter the ones that are already trained because we don't want them. And as well, we filter Rocky because we don't want to train him. So let's concat again. We're going to concat John's dogs and Mary's dogs. So we receive John's dogs. That's okay. We receive them. And then we wait for Mary's dogs. And we wait for Mary's dogs. And they never arrive. And this is a common mistake that we've learned here in Aptoide. Sometimes we have to be sure that the observables we are using, they complete if we want to keep order. If they don't complete, we will be waiting and we will never receive the next ones because we'll be always waiting for the completion event. Since John now uses the dog repository that never completes, that's always open, so we can receive new dogs when they are inserted in the repository, we will be waiting forever. So how do we solve that? A simple approach would be to use the take operator. Take operator will take 3 dogs, and then we will complete. And with the completion event, marriage dogs will be emitted as well, using the concat operator. This is maybe not the best approach, because it's really powerful to have a stream always open for us using the dog repository. But to make it simple, I will show this one for you. So here's the marble diagram. We just take 2 of them, and then we receive the completion event. Nice. So let's talk a little bit about Android. And now we are going to use the Rx findings library. This library was created by Jake Wharton, a famous guy in Android world. And what it does is that he gets the views that are available in Android framework and turn their events into observables. So for example, if we have a button, we can create an observable from the clicks in that button. That's what this rxView.clicks does. So every time a click happens, every time the user clicks the button, we will receive an event. And you can then compose to new observables, to other observables. So what we're going to do, we're going to get these clicks and flat map them into trained dogs. This is a kind of complicated, and probably if you can understand the difference between map and flat map, you are in a good stage in RxJava. So here a click will turn into trained dogs. How is that? Every time a click occurs, that's the circle, it will return an observable of trained dogs, and then emit the items of this observable. So it will emit trained dogs. Every time a click occurs, trained dogs are emitted. Every time a click occurs, trained dogs are emitted. But you see here that the order is not kept. So sometimes you have a click, emit one dog, and then you have another click and emit a different dog, a dog from another observable. So the order is not kept here. Flat map does not keep the order. If you want to keep the order, you have to use concat map. But again, concat map works the same, uses concat. If it uses, it needs a completion event. It needs the observable to complete in order to keep the order. So you see that every click will be mapped to the dogs, and the order will be kept. Okay, listen. So this is the moment where we become imperative and where we are going to perform some side effects, usually in our view. So we have our observable trained dogs. We don't know about the complexity of the chain. We don't know how they are created, if they are mapped, where they come from. But we have an observable of dogs. And we're going to subscribe to them. We're going to start to listen to them. And for that, we pass an observable as a parameter. And you see that we have 3 different kinds of events we can receive. Uncompleted is one of them. It's a terminal event. On error is a different one when an error occurs and you receive a throwable. And finally, you have on next. On next can be called multiple times. It's different from on error and uncompleted. There are terminal events, like I told you. So, another important thing about subscribing to observable is that you receive a subscription. And this subscription is really, really, really important to us. Because you see, we are abstracting something that may be really complicated, that may be happening asynchronously, and that may be using a lot of resources. And if you are subscribing to it, maybe if you are in an object that has a life cycle, and the life cycle of this object ends, you have to tell somehow this observable that you want to stop. If you don't do that, you will get something that happens a lot in Android. You will get a memory leak. You have some asynchronous thing with a reference to your view or to your object that has a life cycle. And when this life cycle ends, if this object retains the reference to your object, you will get a memory leak, or at least you are going to be wasting resources. So we need to unsubscribe. We will need to hold the subscription somehow in our object and unsubscribe when we know we don't need to listen anymore to this observable. There's another nice library, Android library, called Rx Lifecycle. This library helps us to unsubscribe to observables that we don't want to listen anymore. It's maintained by Trello and by Dan Liu, one of the guys that has more experience with ReactiveX and RxJava. So we don't need to do that, but it's really handy to extend our Rx app contact activity, for example, here. But there are other implementations like Rx fragment or any of these objects that has a life cycle. If we do that, we can use the bind to life cycle method. So here we are in the onResume method, and we start to listen to our trained dogs. But we are going to add this compose operator. The compose operator is a different operator from the other ones because he's not going to deal with items emitted by the observable. He's going to deal with the entire observable. So what this bind to life cycle does is to unsubscribe automatically when onPause happens. It can identify that the subscription occurred in the onResume method. So it knows that if you call bind to lifecycle, it will unsubscribe automatically for you when onPause is called. But maybe you don't want to bind to lifecycle. You want to say exactly when you want your observable to be unsubscribed. So you can use compose and bind until event. So in that case, we are going to start to listen in onResume, but we are going only to stop to listen in onDestroy. Another powerful feature that Rx lifecycle provides us is the lifecycle method. So here I'm trying to kind of abstract the idea that the view is an activity, but it's just an example. So I create a name view, and still the type is Rx app compact activity. And we can call lifecycle. So lifecycle will create an observable that will emit each event of the lifecycle of the view. So if you know activities Android, they have several different events, like onCreate, onResume, onStart, onPause, onDestroy, all of them. So we can listen to them. So for example, if you're using MVP pattern, you have a presenter that will deal with your business logic, and you don't want to keep this business logic associated with your view, you can use the life cycle of this view and decouple the logic from the life cycle of your view. And this is cool. You can have your object just receive the life cycle and then deal with all the business logic associated with maybe the view being displayed, and you have to query something. So here we are going to filter the onResume event. We want to do something when onResume event occurs. And we are going to train our dogs. And when the view is destroyed, we want to stop. So there's a reason why I choose to call the compose operator as the final one before subscribe is called. And the reason is that order matters when we are chaining those observables. Order is really important. And sometimes it can be misleading because this, there are other objects like the builder pattern implementation that is also possible to chain the methods. But the order is not important. If you have a builder for a dog, for example, you can set the name, you can set the age. You can set the age first and then the name, and it doesn't matter. When you call build, the dog will be there the same way. But for observables, it's not like that. Order is important. Every time we call a new operator, a new observable is created. It wraps the old one, so we have a new object. So when I call compose, it will affect all the previous observables because I'm calling in the last one that wraps all the other ones. So when it's time to unsubscribe, all of them upstream are going to be unsubscribed. If I change the order and put flat map after compose, it's not going to be taken into account, and it will continue to listen to the trained dogs, and it will be a waste of resources and maybe generate a memory leak. So order is important. Threading. So we have to decide, and we defer this decision. Maybe we can defer this decision to the entity that is going to listen to the observable. But how do we do threading? we have schedulers. So we have different kind of schedulers that are exposed by RxJava. That's the I/O scheduler. That's an executor, an unbound thread pool executor. So it grows as needed, and it's usually used for I/O, for maybe accessing the network or accessing your persistent layer. There's the computation one. The computation one is a pool of threads as well, but it's equal to the number of processors, of cores in your processor. So if you have 4, you will have 4 threads. And it's usually used for heavy computation or for event loops. There's the new thread that will create a new thread every time, so it's not a thread pool. The immediate that will execute in the current thread. And you can customize using your own executor if you want. So okay, let's say that we have old web service implementation. That's a legacy code. It doesn't use observables yet. It will just synchronously grab the dog from the network and return to us. So we're going to use from callable to use this old legacy web service to return our dog. And then going to map him to train dog. Since calling the network can be really, really slow, it's better for us if we stay off the main thread in case of Android. We shouldn't block the main thread because it is responsible only to rendering the screen. We should use a different thread for that. So we're going to use the subscribe on operator to say that we are going to execute using the I/O scheduler. So what the subscribe on does, it says in which scheduler our chain is going to begin operating. You cannot be sure that all these operators is going to operate in the schedulers, in the I/O scheduler, but it's going to begin. So the from callable is going to occur in the I/O thread, in the I/O scheduler, but it can be changed. In my example, I have full control of the chain, so I know that every operator is going to be executed in the I/O scheduler, but sometimes we don't. So we have to be aware of that. Subscribe only defines when the starting scheduler, the one that will, the first operator will go into execute in the scheduler, but afterwards we can't be sure. So what would happen if I call subscribe on 2 times? So only the first one will be valid. The second one will be ignored completely. So it can only be called once in the chain. So here's a different example. What would happen, like I told you before, if instead of using from callable, I use just? It wouldn't work. It wouldn't work because the dog web service would execute before someone starts to listening to this observable, before someone subscribes to this observable. So it will first execute, call the network, and once it has the dog, someone would subscribe and then the dog would be returned. So the querying of the act of querying the dog would happen in the current thread and not in the I/O thread like we wanted to. So this doesn't work in this scenario. So we have to be careful about using just. Like I told you, try to be declarative because then you can explore the advantages of having schedulers. So a different example. We have a view, a text field, and we want to set the text with the name of the dog. So here we'll start to listen to our trained dogs and then set the text. But we have a problem here because, like I told you, we are not sure when, in which scheduler trained dogs is operating. We don't know. But we know that in Android, we have to be in the main thread to modify the views. So the view has to, when we set the text, we have to be in the main thread. We have to be sure that we are in the main thread. So to help us with that, we can use RxAndroid. RxAndroid is a really small library that adds different new schedulers to RxJava. The schedulers related to Android. So in Android, we have a different thread called looper thread that has a looper associated with it. And there's even a special one, more special one, that's the main thread, the one that renders the screen, the main thread. So RxAndroid exposes to us the Android schedulers, and we can use it to get the main thread scheduler. And now we are using the observe on operator. That's different and more powerful than subscribe on. When I call observe on, I'm saying that downstream, every operator is going to execute in the thread I am saying it should. So in this case, it's the main thread. So we are sure that we are safe to set the text here. And here, it's different from the subscribe on. When we call again observe on, saying that we should use the schedulers, the I/O scheduler, it will actually use it. So we can change it. We can change the scheduler dynamically using the observe on operator. So in that case, in that case, schedulers, I/O scheduler is going to be used. Here I'm going to use a different operator called doOnNext that will not change the chain, but will perform side effects in the middle of the chain. So I'm saying that I'm going to observe in the main thread and then call doOnNext so I can safely set the text of the view. And then I'm changing back to schedulers to I/O scheduler. And then it crashes here because we are in the I/O thread, that's not the main thread, and we cannot change the view, the text view. This is a different example that sometimes we don't notice. So in that case, we are saying that we want to observe in the main thread, and then we call doOnNext and safely set the text. And then we call a different operator called delay. It will actually delay every item 5 seconds in that case. So every time an item is emitted, it will wait 5 seconds and then emit the item. But this operator is kind of special because by default, he works in a different scheduler. He operates in a different scheduler. He operates in the computation one. So it will change the scheduler that we're operating. So if we continue, we'll be in the computational scheduler and it will crash. So how do we know that? How do we know that delay does not operate by default in the same scheduler it is chained? How do we know that? Because we read the documentation. We have to be careful about the documentation, about reading it. And this one is really good because it was written by Netflix. So it's really well documented. They have a person there to write the documentation, to review the documentation. But our own observables, we have to document them. Otherwise, people won't know. We won't know where they operate, and we won't know if they are infinite streams, like we shown before the dog repository. And we need to know, because if we want to keep order, we need to know if this stream is going to complete or not. So we need to document that. Finally, we have error handling. So like I've shown you, this is the on error. It will happen only once, and when it does, the stream will never emit items again, unless we do something about it. But by default, it won't. But we have a different option. We can not implement the on error event because there is an overloaded method in subscribe that will only care about the next onNext event and won't care about the uncompleted event and won't care about the on error event. But if we do that and an error occurs, we'll get this exception. And this exception is really annoying. It's really annoying because when it occurs, the stack trace is not helpful at all. You don't know what happened, you don't know where it happened, and it's really, really awful. So what I recommend is you to always implement on error event, even if you want to throw again the exception. So it crashes, but you know where it crashed. If you don't implement it, it will be a really, really, really big problem that we will have. So yeah, sorry. It's not bad, but it's not useful at all. We have to implement. So okay, guys, that's it.